Hello everyone, this PowerPoint slide presentation is on the topic acids and bases. Previously, we have learned the properties of acids and alkalines in our Secondary 1 syllabus. It is pretty much similar, just that we will be learning the concepts in greater detail this time round. Can you think of some examples of acids in our everyday life? Well, I have here citrus fruits which contains citric acid, vinegar which contains ethanoic acid, Coke contains carbonic acid, car batteries contain sulfuric acid, and certain green vegetables contain folic acid. A history on how acids came about. The ancient Greeks used taste to distinguish acids. In Latin, sour-tasting things were described as acri, which is known as acidic and evolved into the term acid. Acidic substances were eventually found not only to taste sour, but also to change the color of litmus paper and corrode metals. In contrast, bases were typically defined and studied by their ability to counteract acids. Now, let's look through the properties of acids. Acids are soluble in water. Acids are good conductor of electricity in aqueous solution. Acids that are very concentrated are very corrosive and can cause acid burns. The pH of acids are less than 7 and turns blue litmus paper red. So, what exactly are acids? Acids form hydrogen ions when dissolved in water. As seen in the diagram, the hydrogen chloride molecules dissociate to form hydrogen ions and chloride ions. The hydrogen ions are the ones that give acid its acidic properties. So, when acids are not in aqueous solution, it actually do not display acidic properties. Next, there are two types of acid, namely strong acids and weak acids. For strong acids, all of the acid molecules will dissociate to form hydrogen ions. So, from the diagram, you can tell that there are no more acid molecules. It has dissociated completely into hydrogen ions and chloride ions. Some examples of strong acids are hydrochloric acid, sulfuric acid, and nitric acid. Please memorize the chemical formula of these three acids as you will need them when writing chemical equation. These are also the acids that we use very often in the lab. Whereas for weak acids, only a small fraction of acid molecules will dissociate. From the diagram, you can tell that most of the acid molecules remain as acid molecules. And if you look carefully, the number of hydrogen ions is much lesser than the strong acids as shown previously. Some examples of weak acid are ethanoic acid, citric acid, and ascorbic acid. Weak acids can be found frequently in our food. We are now going to learn about the chemical properties of acids. From your Secondary 1 syllabus, we have learned the three general reactions of acids. Acid reacting with metals, acid reacting with carbonates, and acid reacting with alkalines. So now, let's go through the first reaction. If you can recall, acids react with metals to form salt and hydrogen. For example, magnesium metal and sulfuric acid reacts to form the salt, magnesium sulfate, and hydrogen gas. How do we identify that the salt was magnesium sulfate? We actually derived it using the names of the reactants. Since we use sulfuric acid, it gives us sulfate salt. And with magnesium metal, that gives us magnesium sulfate. And to add on, hydrogen gas can be identified using a burning spleen. If hydrogen gas is present, burning spleen will extinguish with a pop sound. Next, the second reaction is the chemical reaction of acid with metal carbonates that will form salt, water, and carbon dioxide gas. We shall look at one example. When sodium carbonate reacts with hydrochloric acid, the salt formed is sodium chloride. Carbon dioxide and water are also products of this reaction. Similarly, we derive the name of the salt from the name of the reactants. Please note that carbon dioxide can be identified by bubbling the gas through lime water. What precipitate will be formed in lime water? Some students tend to describe this observation as lime water turning cloudy. Sad to say, teachers will not accept this as a valid answer. For the last reaction, we need to know that acid react with bases to form salt and water. Previously, we have learned it as acid reacting with alkaline, but now we will need to use a different term, base. So, what is the difference between the term base and alkaline? Basically, alkalines are bases. Not to worry, we will learn more about bases in the next PowerPoint presentation. For now, just remember that acid and bases form salt and water. Let's take a look at one example. Can you tell me what salt will be formed when we react nitric acid and copper 2 oxide? If you had understood what I have taught previously, you will know the answer is copper 2 chloride salt and water. And this reaction is a neutralization reaction. So with this, I have come to an end of this PowerPoint presentation. In the next week, we will be learning more about bases and alkalines and their chemical reaction. Thank you for listening.